If we stop at this picture, at the radial engine mechanism, valve mechanism, is it?
Yes, sir.
So gambar yang ni
Saya kata saya nak explain.
sampai sini lah kan? Betul Okay, so this is the radial engine's mechanism. You already know that radial engine is using solid lifter, so the valve is not going to change in volume, so it will be always retain this volume, this shape, meaning there will be gaps. Because for the zero lash lifter, it is going to eliminate the gap between the mechanism from the cam to the lifter to the push rod. There will be no gap because the lifter here is the zero lash lifter or hydraulic lifter. So it will change in volume, so it will eliminate the gap, but not for radial engine. Radial engine is using solid lifter. It will not change in shape and size, so there will be gap between the push rod and the lifter to the cam. So usually, when there is gap, you are going to have a problem because if the gap is not within range established by the manufacturer has already tested the engine and they will have a certain range of the gap. If the gap is too big or too small, there will be a problem. So usually you will measure the gap. How you measure the gap of the valve mechanism is by pushing the rocker arm. Usually, okay, you just look at my arrow in the picture. You will push down this end of the rocker arm and then you will have gap here. So this is where you measure the gap by putting filler gauge. Tahu tak what is filler gauge, Fazil? Then
Yes, sir.
tahu filler gauge what it looks like. Then
Tak tahu.
kau ni apa yang kau tahu? Nanti search Google ataupun tengok buku teks general textbook. Nanti aku rasa aku ada filler gauge ni sama. Let me last time in material and hardware, I think you have done the practical. Ni. Have you seen this kind of thickness gauge? It is looking like this.
Yes, sir.
This is what you call the filler gauge. Betul tak?
Betul.
Mia Tauhid, you still remember filler gauge looks like?
Oh, sir.
Huh?
Yes, sir. Thickness gauge.
So the thickness gauge, you will have different size. So it will be, what do you call it? You will have to choose thickness gauge. There will be a lot of slides. So the slides are of different size. So you need to pick, choose. So when you are doing the gap measurement on the radial engine valve mechanism, so you are going to make sure that the filler gauge is measuring the gap within the acceptable range by the manufacturer. It is in the manual. So you will push down here and you will measure the gap here. Okay? So during this measurement also, you must follow the certain steps that laid out by the manufacturer. So you need to what do you call it? Must measure the gap when the valve is not depressed. When you have the valve is being open, then you will have no gap. Of course. So you need to have the valve not being depressed or open. So the cam lobe will be not pushing up the tappet, the lifter. And then also when you do this measurement, always follow the manual recommendation. And like let's say you have 9-cylinder engine. So this 9-cylinder engine, let's say you want to measure the gap of the valve for intake, let's say. Yeah? So the instruction in the manual will ask you to be in the position where you are going to open the valve at number 9-cylinder and at number 2-cylinder. Let's say this is an example, just giving you the instruction that might be laid out by the manufacturer. So the manufacturer actually wants you to open the valve at cylinder number 9 and cylinder number 2 in order to measure the gap in cylinder number 1. And what I'm trying to what the manufacturer wants is that when you depress at number 9-cylinder and number 2-cylinder, then the middle one, which is the number 1, will be not in depression mode. And then you are going to have the 2 cylinders on their side, on its side, will depress the valve so that it will be pushing down the cam ring. This is the cam ring. So this cam ring, especially for very large engine, there will be gap. Okay, because the engine is too big, the component will be having a lot of gap. And the gap is going to grow. If the engine is small, the gap is smaller. But now you have a very big engine, the gap will be much bigger. So that gap, the cam ring is going to have a gap of its seat. So that is very bad because it will throw out your throw off your reading. The reading must be recommended by the manufacturer in a certain position of the engine. The components of the engine must be in a certain position to get the correct reading. So you need to eliminate that gap by depressing the valve on the sides of the cylinder. When you're measuring cylinder number 1, so the sides are number 9 and number 2. And so you are going to eliminate the gap of the cam ring. The cam ring is going to have a gap of its seat. So that is going to be eliminated. So when you have gap between the seat of the cam ring and the cam ring itself, then you are going to call it floating cam ring. Floating cam ring. In your textbook, so read your textbook. I'm just reading it from the textbook. So floating cam ring. Okay, betul lah tu dalam buku teks floating cam ring. So now this measurement of the gap right here, look at the arrow. When you have the cylinders at the position required by the manufacturer, and then you depress with your thumb, push this down to eliminate the gaps here. Only the gap will be existing here. So you will have the gap over here. So you measure the gap by using the feeler gauge. Okay, so that range must be met. The measurement of the gap must be within the range set by the manufacturer. And also, when you do this, there will be 2 readings. One is when the engine is hot, and one is when the engine is cold. And so you have 2 sets of measurement of the what do you call it? Valve gap. So the valve gap, when it is hotter, it will be Smaller or bigger compared to the when the engine is cold? Ikmal,
Smaller.
smaller. Okay.
Yes, sir.
Kalau engine panas, gapnya smaller ke?
Yes, sir.
Betul?
Ya kot.
Benarnya, when the engine is hot, the gap here you are going to measure is going to be bigger. Why is it bigger? Is because the cylinder will be growing more compared to the push rod. Push rod is a very flimsy. The mass is very small, very thin. So it is not going to grow as much as the cylinders. So the cylinder will have a bigger mass. It will grow more. Okay. And the push rod is not going to grow as much. So what will happen is you are going to increase the gap because the distance between here and the push rod is going to be further as the cylinder grows. Is it correct, Mia? Mia Tauhid, you there?
Yes, sir. When it's hot, it should be bigger.
So when the engine is cold, the gap will be smaller. Okay. When the engine is hot, the gap will be bigger. So you must make sure when you do the measurement, you must make sure what temperature is it going to be. Is it when the engine is hot or when the engine is cold? So you do this measurement according to the temperature of the engine, according to the specification by the manufacturer. Mia, you have question?
No, sir.
You sure?
Yes.
So let's move on to the next picture. So this is the, okay, wait, before that, have I talked to you about the speed of the camering? Have I mentioned that to you? Apa nama? Fazil, you there?
Yes, sir.
Have I talked to you about the speed of the camering?
Yes, sir.
Ada table tu kan?
Yes.
So let's move on to propeller reduction gear. So propeller reduction gear, as you see in this picture, you have the propeller shaft right here, and then the crankshaft is here. Okay. Now, which one has the bigger gear set? Is it the propeller shaft or the crankshaft? Ikmal.
Propeller.
Apa?
Propeller.
Propeller lagi besar. Jadi propeller lagi laju ke crankshaft lagi laju?
Crankshaft.
Crankshaft lagi laju. Very good. Mia, you understand or not? Mia, you there?
Yes, sir.
You understand?
No. Sorry.
No. So as you can see in this picture, the crankshaft here has a smaller set of gears. You see, it's
Yeah.
smaller compared to the propeller shaft, which has a bigger diameter of gear, isn't it?
Yes.
So the smaller gear or the bigger gear is the faster moving. Yeah,
Yes, sir. Is smaller one.
smaller one will be faster, isn't it?
Yeah.
So the propeller will be bigger in diameter, the gear, so it will be slower. Why? Why do we need to slow down your propeller? This is propeller reduction gear. The name itself is showing you the function of it, which is to reduce the propeller speed. So why must we need to reduce your propeller speed? Is it? I thought it was supposed to be faster to go to have more power, isn't it? To have more thrust. So now we are reducing the speed of the propeller. Why? Fazil? Fazil?
Yes, sir.
Kenapa? Why must
So,
we reduce? Apa? Okay, never mind. The propeller speed must be reduced because the propeller is very long. Okay. Some of the aircraft has shorter propeller blades, so you don't have to reduce the speed. But now, usually for engine that is big, you have a very big propeller, and then it will be much longer. So when you have this kind of propeller, you need to reduce the speed. Why? Because you want the propeller to be lower than the speed of sound. Okay? So if you have a longer propeller, then it will reach the speed of sound very quickly at the tip of the propeller. So you don't want that. Why? Why must we maintain the propeller speed below the speed of sound? Reason we reduce the speed of the propeller to below the speed of sound.
Tak pasti sir.
Okay, never mind. That is to prevent stall. Because if the propeller is running at the speed of sound, you know the speed of sound is actually the speed of the air travels through the air. And if the air is vibrating, then you are making the sound. So the sound is being transferred by this moving particle of air, going to vibrate the other sound to the other air particle, and then the other air particle is going to travel and to relay the vibration. And so if your propeller is reaching the speed of sound, it is actually reaching the speed of what the air speed is. The air can travel at what speed? So if the air is denser, then the speed of sound is faster, isn't it? And because it takes a very little distance to relay the message. But now if you are having the speed of sound, so even at denser air, then the propeller is going to scoop nothing. Okay, because the speed of sound is to determine how fast the air can travel. Because if the propeller is turning or scooping the air faster than what the air scoop, you know the propeller is scooping air, isn't it? It will scoop the air to push it to the back. That is how you create thrust. But now the air is not scooping anything because the air cannot not go beyond the speed of sound. The speed of sound determines how fast the air can travel. So if the propeller is too fast, then the air will not be scooped because the air is too slow. You understand what I'm talking about? Fazil? Fazil?
Yes, sir.
Boleh ke tak boleh?
Boleh, sir.
Very easy, isn't it? Okay. So let's talk about the propeller reduction gear. We have several kinds of propeller reduction gear. One, we will have this one. This picture, you call this quill shaft. Okay. So this quill shaft is to prevent torsional vibration. Okay. Why? Because the propeller gear is just mounted on top of it. Okay. So it is very unstable compared to the next one. This one is very stable. But this one, you are putting the propeller shaft on top of this gear on the crankshaft. So it is not going to be stable enough, not rigid enough. Okay? Why? Because let's say you have a ruler. You have a shaft like this. It's looking like cross section is looking like this. So what happens when the propeller is not moving? It is not moving, then it will stay like this. But then you start the engine and the crankshaft is turning the propeller shaft. What will happen is that, you know what is inertia or not? The inertia is resistance to change. So anything in this world, everything in this world will try to resist change. Even you don't want to change. But when it is being forced upon you to change, so the crankshaft is turning and rotating your propeller shaft. The propeller doesn't want to move, but the gears has to move because it is being forced by the crankshaft. So what will happen? You will have a twisting like this. Okay? So that is what you call torsional vibration. It will spring back. It is not going to twist all this time. At a certain point, it will reach stability. So it will, what do you call it? It will have this torsional vibration. You call this springing back. It is springing back to this position. This is the stable position. When you have this is twisting. It is twisting. So it will vibrate. The twisting will be causing that vibration, and it will settle down if it is stable. Okay? Same thing when happens when you want to slow down your propeller. When the engine is slowing down, the propeller is still speeding up. So you are also going to create twisting. That twisting is going to contribute to torsional vibration. When you have vibration, you will lose power because a lot of the power is being changed into vibration, into creating that torsional vibration, which is very bad. So that is why we install a hardened shaft. You call it the quill shaft. The quill shaft is made of very hard alloy. So where is it? Quill shaft. Hardened shaft that is plied on both ends and installed into it is just a hardened metal. I don't know the composition of it. So, but it is a hardened shaft. So when you have it hardened, then there will be no twisting, or you minimize the twisting. So because it is rigid, it is hard, and it will not be able to twist very easily. So that is how you prevent torsional vibration. Because when you have a picture, which is the sun gear. Okay, so this is what you call the planetary gear system. Now you have the propeller is attached to the middle. So this is propeller fastened to the spider. This is called the spider, and the propeller is mounted at the center of the spider, which is very stable. If it is at the center, it will be much more stable and rigid compared to this kind of propeller shaft. So this is much more stable and much more rigid. So it consists of sun gear. Sun gear is the middle gear. Then you have the planetary gear, which is on the side. And then you have the ring gear. Ring gear driven by crankshaft. Okay? So the crankshaft is driving this ring gear. Then when you have the ring gear rotating, you are also making the spider to rotate, but at a certain slower speed. So the purpose of this planetary gear is to reduce the speed also, but at a much stable configuration. So it is usually used on radial engine. Why? Because radial engine has 18 cylinders. They are producing very huge power. Then you will not be able to eliminate the torsional vibration by just using quill shaft. You need to have a complex system that is going to be much more stable like this. So if you have this planetary gear, it is much more complex, it is heavier, but it is stable. So for higher speed engine, higher performance like radial engine, they are going to use this planetary gear system. So the speed of the planetary gear is, according to your textbook, I'm just reading your textbook. So it is the ratio of teeth on the ring gear plus teeth on the thumb gear divided by teeth on the ring gear. Okay, so you can read it from your textbook. You have it in the textbook or not? Siapa nama ni?
Yes,
Iqmal.
sir.
Ada
Yes,
dalam
sir.
buku
Ada.
Thank you. Okay, so no question? No question, Okay, if there is no question, we move on to propeller shaft. Okay. If you look in this picture, this is where you mount your propeller. Okay? So we have different kinds of propeller shaft. So the first one is this one. You have this tapered propeller shaft. You just put the propeller. Okay, that is why I want you to come back here. If possible, you need to come back here and see it for yourself. If not, you need to search YouTube for this picture. This is called the tapered propeller shaft. You put the propeller. Usually, the propeller is fixed pitch. Fixed pitch propeller. Usually, it is made from wood, and you just put it inside, and supposed to be a tooth is installed here. It is a metal tooth. You are going to put in this groove so that it will grip the hub of the propeller. So what is gripping the propeller hub is only this one tooth. That is why it is being used on very low performance small engine craft, like 4 cylinders, or maybe 1 or 2 cylinders, 4 cylinders. You are going to use this kind of propeller shaft, the tapered one. Because one tooth is holding the whole propeller and drive it to turn it. So one tooth only is being used to turn the whole propeller. Okay. Then the next one, this is the one that is for high performance, like radial engine. Usually you have this radial engine propeller shaft. So the propeller is being slotted in. The hub is going to be driven by several teeth. So if you look in this picture, you can see that on this side only we have 1, 2, 3, 4, 5, 6, 7. On this side only you have 7 teeth already. So maybe plus the other side, maybe you get another 7. Maybe. Or just the whole thing is 10 maybe. So 10 teeth are going to turn the propeller hub. So you have much better grip, turn the whole propeller. This is usually for radial engine. And for radial engine, usually the blade is variable. The propeller is a variable pitch propeller. So for variable pitch propeller, it is going to be very big, very long, very complicated. It is heavier, because you have all the components that is associated with variable pitch propeller. So for that kind of very heavy and complex and huge propeller, usually you will match it with the bigger performance engine, like the radial engine, like 18 cylinders, 9 cylinders. And then the next one would be the flange type. Flange type propeller shaft. You see here, so the propeller hub is going to be attached here, this surface, and on that surface, you are going to be installing bolts. Like in this picture, you have 6 bolts. 1, 2, 3, 4, 5, 6. So 6 bolts are going to grip on that hub and turn the propeller. It is like your automobile wheel. You install your tire at your wheel at the wheel hub. Then the bolts are the ones gripping and turning the wheel. Same thing with the propeller here. It is being driven by the these 6 bolts. So it is very simple. This is usually used for 6 cylinders or maybe 8 cylinders. But for radial engine, you use the spline shaft. This is what you call the spline shaft. You just read from your textbook, it is there. This is spline shaft, this is tapered shaft, and this is the medium one, which is the flange. Maybe 6 cylinders or 8 cylinders. This will be the radial engine. This is for the 4 cylinders. Okay, very simple, isn't it? Any question? Yeah, no question? Yeah, you there?
Yes, sir.
You got no question?
No, sir.
Next one, we will go to engine identification. So engine identification, usually there will be a data plate. So on your engine, on your crankcase of your engine, there will be a plate. Every component in the aircraft will have this data plate, including the engine. And the engine data plate will be on the crankcase. Usually it is on the crankcase. And that data plate, they will describe what kind of the engine, what is the name, what is the make, what is the dimension. So all that is on that data plate. And there will be a coding assigned to it. So from that coding, you can understand the characteristic of the engine and also the, what do you call it? The characteristics but set by the manufacturer. So you can see the coding of that identification in your textbook. So let's say your engine has this coding O3 O320. O320 means it is an opposed engine. O stands for opposed. 320 means the cubic inch of the what do you call it? Displacement. So what is displacement? So this is displacement. Looking at the picture here, you see my arrow is moving. So the what do you call it? The displacement is the volume that is being displaced from the cylinder. So this is your inside your cylinder. So here is where the piston is at the lowest point. That is called the bottom dead center, BD. See? And then here you have the piston at the topmost position the piston can go. We call it TDC, top dead center. So between here and here, this is the region where your piston is moving. So the distance where you have your piston moving is the distance where you displace air in your cylinder. So the volume from here to here, this is what you call the displacement. Displacement means how much the air is being removed from the cylinder, or you suck in air. And so that is the volume we are talking about. the displacement. So if your engine has bigger displacement, and like your automobile, let's say you have a Perdana, your Proton Perdana is having the displacement of 2.4. That means 2.4 liters. 2.4 liters? Yeah, something like that. That is in metric, but here you are talking about in inch, cubic inch, and it is the English system, the American system. So if for Kancil or maybe like your Baja, it is 1.6. So it is a smaller displacement, meaning the engine is displacing this much of volume. For the 2.4, it is displacing this much of volume. So the more displacement you have, the more stroke you will have. So the more stroke you will have, the more power you will generate. So the bigger CC means the more power you are going to put. Okay. So that is the identification. So you just read on your own in the textbook. The engine identification. So there's also an example. The GTSIO 320F. 520F. So GT can oppose engine. So that's given to you an example there for you to understand how to what do you call it, translate the identification. It is already given to you the meaning of the coding. Okay. The next one will be this. Okay. So this is the 4-stroke cycle. 4-stroke cycle engine or auto cycle engine. So you have the first event. You see the piston is moving downward, and then the compression, the piston is moving upward. You see both valves are closed. Right here in the intake, you see the intake valve is open, but now at the compression stroke, both valves are closed. And then the power stroke, you will see actually the power stroke, this intake should be closed. The picture is not really accurate. And so both valves are closed still, because this is where you have the pressure build up due to the combustion. It is pushing down the piston. So this is where you have the power stroke, where you have the combustion pushing the piston to give power and rotate your crankshaft. Okay. And then at the exhaust stroke, you see the valve, the exhaust valve is opening and the piston is going upward to push all the exhaust gas out through the exhaust port. Okay? So that is 4-stroke cycle engine. It requires 4-stroke. 1, 2, 3, 4 to complete all 5 events. What are the events again? A, compression, ignition, power, and exhaust. But now you have a 2-stroke cycle now. Usually this is for your motorbike. You have only 1 cylinder. So that 1 cylinder will need to what do you call it? Have the momentum continuously. So you cannot have it to turn 2 revolution because the momentum will die off. So it needs to complete everything in 1 revolution. 1 revolution, everything has happened. The intake has happened, the compression, the ignition, the power, and the exhaust, all are going to be completed in 1 revolution. This is for maybe for your motorbike or your lawnmower, where you have only 1 cylinder. So it's going to be mixed with the fuel. Okay? So like tutti oil is mixed with the fuel to lubricate get the component of a single cylinder engine. So because there is no, the system is not going to be very complex, like the 4-stroke cycle engine, the auto cycle engine, they have more than one cylinder. So when they have more than one cylinder, the system can be more complex. The oil will have its own system, but now for the 2-stroke cycle engine, only one evolution is required to complete everything. So the system is not going to be segregated. You want to make the engine as simple as possible, as lightweight as possible, and make it simpler. So you are going to mix the fuel with the engine oil. Even then also the oil, the fuel will not be totally burn out, totally burn off during the combustion, because there will be some of the fuel be left unburned to aid in cooling. Okay, the manufacturer has purposely set it like that, make it slightly richer so that some of the fuel will not be burned to aid in cooling and to lubricate and whatever. Okay, same function as the lubricating oil. So here is where you have the first, you have the check valve opening. This is the fuel coming from the carburetor, fuel air charge coming from the carburetor, and it will be stored at the crankcase. While the piston is moving outward, the space in the crankcase will be getting bigger because the piston is moving upward. And then during when the piston is going to be taken place, and you are going to see that the exhaust port is going to be opened by the piston. Exhaust port first will open to let out all the exhaust gas out, and after that the intake port to the cylinder is open. After the exhaust has opened, the intake will soon open to make sure all the exhaust gas being removed through the exhaust port by having the fresh air and the fuel mixture being pushed downward to force it to go inside the cylinder and remove all the exhaust gas out. So that's how the 2-stroke cycle works. It is not really efficient as 4-stroke cycle like the auto cycle, but it is a small engine. It is only one cylinder. But if you have many cylinders, then you can afford to have a more complex system, a segregate system, which is much more efficient. Okay? So this is the picture of the simulation of the whole. Okay, this is giving you the events that was supposed to take place in one cylinder. So one cylinder will have this event, these events occurring to them, to the cylinder, to the individual cylinder. Okay, so it is a bit complex and a little bit not really clear. So what I do is to give you a better schematic. Let's okay, see this, but can you see this or not? This is what you call power W. Can you see it, Mia? Yeah, you there?
Yes, sir.
This is what you call the power W. It is a representative of the picture showing you the events. So this picture, the one that I shared you just now, it is really very tedious to look at. It is very cumbersome, very hectic. So it is not really clear. So what I do is I make a power W diagram. So to look at my drawing here, it is showing you what is represented at the diagram before this, the circular diagram. Now all the event can be clearly seen here when I put there. Okay. If you look in this picture, I've already what do you call it, label certain part of the movement. Okay, this is showing you the movement of the piston. Piston going downward, piston going upward, downward, and upward again. So those are the 4 strokes. 1, 2, 3. So let's look at what happens when the piston is going down. Here is the intake stroke. So this is the intake stroke. You see the intake opens, the valve is opening slightly before it reaches the top dead center. When the piston has reached, before it reaches the top dead center, the intake oil is already open. The intake valve is already open slightly before the piston reaches the top center, top position. And then when the piston is going downward, this is the intake stroke. So it is sucking pure air charge that is from the carburetor going into your cylinder. And then when the piston already going up again, then the intake valve closes. Then here is the compression stroke. Now during this compression stroke, you have the ignition happening slightly before the piston reach the top dead center, top position. Then when you have the piston going downward again, then this is what you call the power stroke, meaning the combustion pressure is pushing the piston downward to move the piston and to rotate the crankshaft. You will have the exhaust opening just before the piston reach the bottom dead center. Then when the piston is going upward again, this is the exhaust section. So it is having the piston pushing out all the exhaust gas out through the exhaust port. And slightly before reaching the top dead center, the piston reach top dead center, then the intake valve is going to open just before it reach the top dead center. You see or not? So it is a very complex system. Very complex event. If you look at the picture that I've shown before, like this one, so you are going to have trouble looking at it because it is much complex and too much overlapping information. So that's why I don't use this one. I'm just going to use the what do you call it? Power W, the one that I just draw and show to you. This is the Power W diagram. Okay, it is much easier for you to look at and to know what is going on. Okay, so from this picture, you can notice that the valves are not going to open at the peak. Not opening when the piston has reached the top dead center or bottom dead center. The valves are opening slightly before the event. So why is that? And last time, the one invented this engine, the 4-stroke cycle, the Otto apa nama dia? Mr. Otto lah. So that Mr. Otto is going to open intake valve at the peak and then closing the intake at the bottom, and then you have the both valve close, and then you have the ignition at the peak, and then the exhaust opening at the bottom of the DDC, the bottom dead center of the piston. So the first trial is was very bad because engine was rough running. The engine was vibrating violently, and what do you call it? Then the engine will die off very quickly, and because too much vibration, too much explosion, detonation, and due to pre-ignition and everything. So Mr. Otto was very unsuccessful the first time. So he made adjustments to the opening of the valve and also adjusting the firing, spark plug firing at what position of the piston. And so what Mr. Otto has discovered was that everything will be very smooth, will run very smoothly when you have it arranged like this. You need to open the intake valve slightly before it reaches top dead center. So this configuration is the one that is producing a much more smooth running of your engine. So why is that? What is the reason? I will tell you next week.